then I realized that maybe I should introduce blockchain in the first for people who are maybe not used with it. So to start with, I'm Etienne. I'm a Swiss guy who used to work at a leader in online banking in Switzerland as an operations engineer. I moved in June in Vietnam to work at Tomochain as a Devops engineer. I'm a free software enthusiast and I really like keyboards, so if you want to talk about that, we can. A bit about Tomochain. So it was founded in 2016. It was called Tomo App back then and was a software company. In late 2017, they went into the blockchain industry and renamed Tomochain. We are a bit more than 20 people working in our office in Hanoi. The company started and wanted to create the blockchain Tomochain to address the scalability problem of Ethereum. Ethereum is a big blockchain who is maybe the second well-known after Bitcoin. Ethereum is quite known because you can run applications in the blockchain. So the only problem is that it's really slow. So our goal is to make a blockchain who can also provide a platform for decentralized applications, so applications who use blockchain, but with great performances, really slow transaction time, and so we also really promote the Internet of Value by doing some conferences and explaining blockchain to people who never heard about, who don't know how it will help them. So a little basic explanation about what is a blockchain. So blockchain is a chain composed of blocks, of course. Each block contains his cryptographic hash and the hash of the previous block, and some data. The data can be really different. We can have some transactions, the information about accounts of people, and smart contracts. Smart contracts are the same as if we put computer code in the blockchain. It means that when you put, you can really put some kind of programs in the blockchain and then call them. So if you just think that it's some blocks, one after the other, who contains the address of the previous block, what is the difference between the blockchain and a linked list? Actually, the difference is that everybody can consult the data of a public blockchain, and the data is decentralized across a lot of nodes, so you can't change the data who has already been put in the blockchain. It means that a data who has been written to the blockchain will stay here forever. To manage a blockchain, because we have it's decentralized, and we have to find a way for all the nodes to agree together about which blocks are legit blocks who contain the right information, and which blocks are bad blocks who could be maybe issued by an attacker or something malicious. We want to have a mechanism to know which blocks have to be propagated in all the blockchain between all the nodes. So this is done by the consensus. So this is between all the block producers, all the machines who will generate new blocks. This is really important for the security of the blockchain, because it defines, it will make that if someone creates a new block with malicious information, for example, a fake transaction, for example, if someone tries to say that everybody give him some money in a transaction, the blockchain should have a mechanism to know when a transaction is not legit, and this also really impacts on the performances and the way the centralization or decentralization of the blockchain. There is a quite famous theorem called CAP, which means consistency, availability, and partition tolerance. So it's a theorem that says that in a distributed system, there is always those three value: the consistency, availability, and partition tolerance. So the consistency is that when you ask for data, you should always get the latest data on every node that you ask. Availability is that if some nodes in the blockchain doesn't work, you should still able to retrieve some data in the best time. And partition tolerance is just to assure that the system will continue to work even if a part of the blockchain of the nodes are not working. So the CAP theorem says that when you make a distributed system, you always have to sacrifice one of the points. You can't ensure all three at the same time. So our way to do it, to assure the best performance, availability, and consistency, is that we sacrifice a bit of decentralization by allowing only 150 nodes, machines, to participate in our blockchain. So the blocks will be created only by 150 machines. So we call this kind of consensus proof of stake voting. Proof of stake voting. So we have the block producer, we call them master node. So all the servers who will be accepted in the system and who will produce new blocks, they are called master nodes. Every people who own the currency of our blockchain, the Tomochain, they can vote for the master node they want to see in the top 150. So everybody can apply to be a master node, and they are put in a list of candidates, and people can see, depending on their stats. For example, if they see a server who is really powerful, they will vote for him, and if he made it to the top 150 voted servers, he will start to produce blocks. So when you think about that, you will say, why will people vote for master nodes? Like, why will they spend their time voting? What is the incentive to do that? So actually, we have a reward system. So people who vote for master nodes, they will receive coins in return depending on the performance of the master node they have voted for. So for example, let's say they vote for a master node, and this machine is not well maintained and it's down maybe half of the time. So this machine will not produce a lot of blocks, and the people who voted for this machine will not receive a lot of reward. So there is an incentive to vote for good machines, for the people who vote to get good rewards and make money. And it makes sure that the network always stay with the faster and stronger servers and keep the system really fast. And we also implemented for the security region something called double validation. It means that when a new block producer, when a new master node creates a block, it will be verified by the next master node in the list and also a random one in the list of master nodes. So this ensures that no attacker to be able to change the data in a block or to spread a new bad block containing fake data should have to hack, for example, a lot of the servers to be sure that the next one in the list and the random one in the 150 are both blocks who masternode who are in his control. So our consensus system really rely on the game theory. So the idea that the people who are voting for masternodes will always try to have the best for their interest and earn the more money. So because in its essence the blockchain is a public blockchain, is really transparent and made for data to be public and really reliable, it's really important for people to trust it, and for people to trust it, we use open software. So all the code base, the configuration of our infrastructure and our programs, the builds, the Docker images, the tools we use, even the metrics of the servers, and all the data of the blockchain, of course, and also our API are public. So basically, everybody can see all the part of our infrastructure and data, and they can review it and make an idea by themselves if they think it's reliable to use with their own system. So part of our infrastructure, we have this website which is called Tomomaster, which is really important. This is where all the governance happen, so where people, holders who have Tomochain can vote for servers and also apply. So on this server, on this website, you have the list of all the candidates to be masternodes. You have the stats. We don't see it in this screenshot, but on the detail of every server who applied, you can add stats like the CPU, memory usage, to be sure that you're voting for a reliable machine. It's using Node.js and MongoDB. And you can also see from this website the rewards you received from voting. So it's really the central point, like the heart of our system, where we really organize the blockchain. We also have another important part, is Tomochain. This application is made for exploring the blockchain, so you can really see every block, see the data inside, you can see the transaction, all the accounts, you can see the code which is deployed in the blockchain. It's really transparent, so it means that everybody can access all the data that is in this blockchain. It's also using Node.js and MongoDB and Redis. We also have, of course, the blockchain software in itself. The implementation of our blockchain is based on the Ethereum code base, so it's a client in Go. This page is obviously not the software, but a website who gives the stats in real time of the blockchain. You can see the nodes producing blocks and all that. So for creating an infrastructure who is open and public, who is really transparent, we realize that we have a lot of different technologies because we use different services, our own applications, and also external applications, like for example, for the logging, we use for visualizing metrics, we use Grafana. So we have a lot of different technologies. So for having a better way of deploying all of them and managing them, we choose to use Docker. Because we use so many different technologies. And it's really easy to automate and integrate any application using Docker, because when it's in a Docker container, wherever you run it, if it's on your local machine, if it's on the production environment, if it's on the staging environment, it will always work in the same way. So we use Docker to automate integration and delivery. And when I joined the company, we were already using Docker Compose for local development. So using Docker Compose, we can really easily switch to Docker Swarm for using on the to deploy on the different environment. The advantages of Swarm is that it lets you really manage each services, automate where you update each services, and you can easily scale. But in our case, we don't really need scaling so much because we need powerful machines for the blockchains to run, but we don't have any service who really need horizontal scaling because of maybe so much access or something. So for now, we just use Swarm. It really fits our needs. So about the pipeline, so we try to make the pipeline the more efficient possible to save developers a lot of time. The goal is that they spend most of their time developing and not worrying about their code being put in the right environment or being tested. So what happens is that our developer or even a contributor who will contribute to our software using GitHub, because all our code is public, so everybody can contribute. We'll implement a new feature. He will make a pull request on GitHub to add his new code to the main code base. So this is manual steps because we have to ensure that the code is valid and good quality. So we have to review every pull request to be sure that it meets our needs. But once we merge the pull request and the new feature is added to the code base, we will have Travis, which is a service who will automate the build and test of the program. So every time we have a new version, he will run the test we predefined. So we can, without doing any extra manual step, know if the program still works with the new feature. It also built a new Docker image and push it to Docker Cloud. And on Docker Cloud, once we receive the new Docker image, we will run the integration test, which means not only testing the application by itself, but in the environment. Like, will it still work? Will it still, is the call to this service will still work? So we need to see if it fits with the other application and if they still respond nicely together. And on our server, so we have Docker Swarm, who will actually watch for changes of the Docker image. So if Docker Swarm on, for example, our development server will see that there is a new image, it will automatically pull the new image and deploy the new version without any extra step. So of course, on production or staging, we don't want everything to be automated because we want to really ensure that we know what version is running for better control. So this step is only automatic in, for example, development environment. And each of these steps, the user who make the new feature can have a feedback. He can know at every moment if the build on Travis worked, if there is a problem with his code, if the integration test work, and finally he can just see in the development environment, he can see his new website or new application running a few minutes after he deployed it. And of course, if one of those steps fails, it doesn't go further because obviously we don't want to deploy on the server an application who didn't pass the build stage or the test stage. So because it's really open and everybody can participate, there is different way of participating. There is the way if you want to participate in the technology, if you're maybe a developer or something, and everybody can contribute to our platform. And everybody can use our platform to deploy decentralized applications, so applications who use the blockchain. Also, everybody who see that there is a problem with our system when they use it, they can open issues on GitHub so we can correct it. You can also participate as running a masternode, so being part of the infrastructure itself. For that, we have different ways. So we provide a script called TMN, who is made to run a masternode really easily on a machine. We provide the Docker images. For example, if a company already has its own infrastructure with maybe Kubernetes or some cloud platforms, maybe they want to integrate really better with their own infrastructure, so they might use our Docker images directly. Or you can even run the Go client natively on a machine. We have documentation for all those steps. And the people who own Tomochain, who are usually more investors than tech people, they participate in the environment by voting and ensuring that they always keep the best masternode and the best performance for the network, and they gain money by this way. So for the demo, I will just show you how we can really easily add a new masternode to our network by running our script. So I'm going to video. So by running this script, you need to indicate. So when we run this script, we have to give a name to our masternode, so it can be recognized in the voting application that I showed you before, Tomomaster. We have to give him the environment, because we have three environments: the DevNet, who is the development environment; testnet, who is like a public staging environment. It runs the version that we want to put in production next, so people can try the latest version, but it's a stable latest version. So people who also want to create new applications using our blockchain, but they don't want to have to pay any transaction fees by using the blockchain, they can use the testnet, which is all free. And there is the mainnet with the production blockchain, who contains the real data. It means the money of all the holders, the real code, and the real transaction. So for this example, we'll just join the DevNet. So we can see that the script is creating the Docker resources. So we have the volume, who will be holding the blockchain data, the network used by Docker, and two containers. One container for the metrics, who will be in charge of sending the stats about the server to our central in our application. So this will send, for example, the stats about the CPU, the memory, the usage of the disk, the bandwidth, and that let us have on our website the stats of each masternode, and to help people decide which one to go. So once it's launched, you can see that both containers are running. And if we go on the stat page, we can see normally. If I refresh the page, we can see that now we have this container, who is the demo container that I just created. And on the right, you can see the number of blocks synchronized is still at 0, but after some time it will start to sync with the blockchain. So the next step will be to go on the Tomo master to apply our new master node. So it will appear in the list of candidates, and people could start voting for the master node. And if it goes in the top 150, instead of just synchronizing the blockchain, it will start to, it will take part in the block creation. So every 150 blocks, it will be his turn to create a new block. And the people who voted for him will receive reward. So what's next for our blockchain? Last week, we released our new testnet. So our new testnet is the public testnet that people can use for testing our blockchain. And it was at this moment that we released all the flow with the Tomo master and the voting, the new consensus. So it was the first time we really released and made public our new system. And in Q4, at the end of the year, we will release the mainnet, so the definitive blockchain who will contain the real data and the real transactions at the end of the year. And there is a big debate about how to make the performance even more scalable, because in the future maybe we will have a lot more websites and applications using blockchains, so maybe we will need even more power than we have now. One of the ways of doing that is sharding, and a lot of blockchains are thinking about how to implement sharding in their blockchain. So at the end of the year we should have our own implementation of sharding enabled on our testnet. And Q2, so in the start of 2019, we should implement the final version of sharding on our mainnet. So of course there is all the important stuff that will happen. For example, the creation of our application Tomo Wallet for all managing currencies, decentralized exchange. We have a lot of other stuff coming, but the most important point from technological point of view is those ones. And so finally the question. Thanks for listening to me. And if you have any questions, we'll be pleased to reply. Yeah.
I have a question about your CSV. How do you like to do the database migration in the CSV?
The migration?
Yeah, the DB chain during the deployment. Do you guys have change in the database between the deployment?
The migration of the DB, you say?
Yeah.
You mean the data of the blockchain?
Yeah.
The thing is that for now, people who, you mean, for example, people who already have maybe buy some Tomochains, and
I mean that in your system, do you have any database like MySQL or kind of that?
We have some database we use primarily for our decentralized application. We use MongoDB.
Yeah. So during the deployment, do you have any change, and how do you handle that automatically?
Actually, the database we use are mostly filled up with data that we get from a crawler who will crawl the blockchain to retrieve some information. For example, Tomochain, who lets you get information from from the blockchain. So if you want to see a transaction or the content of a block, we have a crawler who will get the info of that block and put it in a database. So actually the contents, like how the database is organized, will not really change because it really links to the format of the blockchain, and it's not really going to change. So we don't really have so much migrations of databases to do, and they are also containerized, so we can easily update the version of the DB or some stuff without too much hassle because the data is separated. So yeah. Did I reply to your question?
Okay.
Okay.
So do you have any question for Etienne?
Have one?
Yeah. Have one question.
Can you explain more?
Hey, I have a question related to double validation.
Yeah.
I want to ask how you regard to double validation, how you restrict, like, for example, node A collude with node B to affect the system.
Sorry, can you repeat?
How do you stop, for example, like node A in your blockchain collude with node B to attack the system, the whole system.
So you mean that block A generates a block and block B is the validator?
Yeah, validator A collude with validator B.
Yeah.
To attack the whole system.
So this is the first step of the validation, right? And then we have the second step, who will be choosing a random, with true randomness in one of the 150 nodes. And this guy will validate also, so we always need the two validations. And the randomness of the second one really adds a layer of security, because if you want to be in control of two master nodes to propagate a bad block, given the randomness, you really have to own a big part of the network to be able to propagate bad blocks, or be really, really, really lucky. But, yeah.
Thank you.
Thank you.
Any other question for you? So it looks like we do not have any.
Okay, cool.
Yeah. So
Thank
thank
you.
you, Etienne, for your great.
Thank you.